Hello, my name is Dhananjay Bhandarkar. I am presenting the way we predict the insurance premium from a given data set. So, the data has explanatory variables like age, sex, and the region where they belongs to, and whether the user is a smoker or non-smoker. Based on that, we have already pre-filled insurance paid details, which we consider as a target variable. Uh, so now our challenge is to predict insurance premium for a person when he comes to the organization to offer insurance. So while analyzing the data, uh, while analyzing the given data, so it is observed that there are more number of non-smokers compared to smokers, and among the smokers, there are more men used to smoke compared to female. So we can make a slight estimation that the men will be charged more for while they are opting for insurance compared to female. So let's move ahead. So when we have distributed the data set uh, by smoker and non-smoker, it is observed that the more number of, the more price has been paid by the smokers while compared to non-smokers. Um, so since we see in the first graph, the expense range is more for the smokers while comparing to the non-smokers. So we predict like the smokers tend to get more insurance premium. They are going to charge more insurance premium compared to the non-smokers here. Okay, so let's distribute the uh, expenses borne by the person based on their sex. It is observed that both men and women are charged almost equivalently. I mean, there is no much discrimination between men and women when premium was charged to them. So we can say the sex column will not make any sense for us. So we'll see when we do a EDA on this. Okay, so when we when we describe the insurance data, it is found that the mean is around 9,382, uh, and the median is around 13,270. So there is a highly difference between mean and the median. Uh, So looks like it will be skewed. The expense data will be skewed, and we have to make some data treatment for this. So looking into the expense data, so as we seen from our uh, table or described data, right? So we see that expense are rightly skewed, and it is not a perfect normal distribution. I mean, it's not more likely to normal distribution. So we have to make some cleaning here in we need to tune the data here. Okay, so the way we used to tune the data is using the log application. So when we apply a log, so the expense data tend to become a more likely a normal distribution now. So we'll apply since the target variable is the continuous, we'll apply the regression models and see which model best fits this data set. Okay, so when we plot the correlation data in uh, explained variables, so it is found that none of the explained variables are highly correlated with any other uh, variables. So what we can do here is we can consider all the explained variables. So there is no point of dropping any column here, since none of the variable column are highly correlated. Okay, so let's plot a linear regression. From the linear regression detail, it is found that RMSC value is around 0.44, and R square data is found out to be 0.78 and 0.77. So that is for the R2 and adjusted R2. And when we derive the coefficients, so we derived all the five coefficients for that linear model. Okay, so then we have predicted the score for this linear regression that comes around 0.78 for a linear regression. So then we move to the polynomial regression for the degree of 2. Here, while predicting the uh, target variable, so with the polynomial regression, when we plotted the score turned out to be 0.85, which is slightly better than the linear regression. And since we consider this as to be a best fit compared to the linear regression, and we have to untransform the data which we have applied a log for the expenses. So uh, by reversing that log, I mean by inversing that log, so we have derived the target variables here, and by making use of these coefficients, and when we have a new customer, so we can easily predict the insurance premium that the person has to pay when he apply for the insurance. Okay, so also we have drawn the random forest regressor. With the random forest regressor, it is seen that RMSC value turned out to be 0.97. Sorry, RMSU value turned out to be zero point 0.4, which is similar to the linear polynomial regression or the linear regression. And the adjusted R2 square value is more here, I mean 0.97. So while we compare it with the linear regression, it was around 0.76, 0.77. So here we turned out to be 0.97. So which is so we can say by looking into that uh, 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 linear regression and the random forest regression. So we have selected this random forest regressor as to be best fit model for our given data set. Okay, so we have predicted the score. The score turned out to be 0.84, which is almost same as polynomial regression score. And since we can consider both polynomial regression or the random forest regressor for predicting the insurance premium. So that is the conclusion from here. Thank you.